Imagine this. A liquid, thick as honey, turns solid in a blink. No magic, just science. This is the power of Magnetorheological fluids, or MSAR fluids for short. These fluids can change their viscosity, their resistance to flow, on demand. And how do they do it? With the help of magnets. Mester fluids are suspensions of tiny iron particles in a carrier fluid like oil. When a magnetic field is applied, the iron particles align with the magnetic field lines. This alignment transforms the fluid from a free-flowing liquid to a semi-solid state in milliseconds. From shock absorbers in cars to earthquake-resistant buildings, Mester fluids are transforming technology as we know it. So, what's the secret sauce behind this magical transformation? It all boils down to the interaction between the iron particles and the magnetic field. Picture this. Billions of tiny iron particles, each like a miniature compass needle, are randomly dispersed in the fluid. Introduce a magnetic field, and the party transforms into a synchronized ballet. The magnetic field lines pull the iron particles into alignment, creating chains that resist the flow of the fluid. The strength of this effect depends on the strength of the magnetic field. Engineers can precisely control the stiffness of the fluid by adjusting the magnetic field strength. This opens up a world of possibilities for creating adaptive systems that can respond to changing conditions in real time. From shock absorbers that adjust to road conditions to prosthetic limbs that provide variable resistance, the applications are groundbreaking. The unique properties of ester fluids have captured the imagination of engineers and scientists across various industries. One area where ester fluids excel is in damping and vibration control. Think of a car's shock absorbers. Traditional shock absorbers struggle to adapt to varying road conditions and driving styles. Mester fluid-based shock absorbers can adjust their damping properties on the fly. Sensors detect road conditions and driving dynamics, sending signals to adjust the magnetic field applied to the MR fluid in the shock absorbers. This allows the car to seamlessly transition from a smooth ride on a highway to a sportier feel on a winding road. But the applications of MR fluids extend far beyond the automotive industry. Imagine buildings that can withstand the devastating forces of earthquakes, swaying gently instead of crumbling. Mester fluids are making this vision a reality. By incorporating ester fluid dampers into buildings and bridges, engineers can create structures that adapt to seismic activity. These dampers work by counteracting the forces imposed on the structure during an earthquake. As the ground shakes, sensors detect the movement and adjust the viscosity of the MR fluid in the dampers. This allows the dampers to absorb and dissipate the energy from the earthquake, minimizing damage to the structure. This technology has the potential to save lives and protect critical infrastructure from the devastating effects of earthquakes. Mester fluids are also used in precision machinery, where even the slightest vibrations can affect performance. The automotive industry is undergoing a revolution, with electric vehicles and autonomous driving taking center stage. Mester fluids are poised to play a crucial role in this transformation. Imagine a car that can adapt to your driving style, seamlessly adjusting suspension, braking, and even the feel of the steering wheel. Mester fluid-based clutches and differentials can provide lightning-fast response times, improving acceleration and handling. These systems can also enhance the efficiency of electric vehicles by optimizing power delivery to the wheels. And with their ability to provide haptic feedback, Mester fluids can create more intuitive and responsive steering systems, enhancing the driving experience. They can also enhance safety by sensing an impending collision and instantly adjusting the suspension to minimize the impact. Mester fluids can make this possible, potentially saving lives by reducing the severity of accidents. The future of Mester fluids is brimming with possibilities. From flexible electronics that can bend and fold without breaking to wearable exoskeletons that enhance human strength and endurance, Mester fluids have the potential to revolutionize our world. In the field of medicine, Mester fluids are being explored for targeted drug delivery systems and minimally invasive surgical tools. Imagine tiny robots controlled by magnetic fields, delivering medication directly to diseased cells or performing delicate surgical procedures with minimal damage to surrounding tissues. This could transform the way we treat diseases and injuries. As we venture further into the 21st century, Mester fluids stand as a testament to the power of human ingenuity. These remarkable fluids, with their ability to defy expectations, hold the key to unlocking a future where technology seamlessly integrates with our lives. The magic of Magnetorheological fluids is just beginning to unfold, promising a future limited only by our imagination.